So you got all your parts planned out and you're ready to build, but what thermal paste are you going to use? Does it even matter? Well, that's why I'm here. We're going to find out. So you just got your build planned out and you're about ready to order all your parts and put your computer together. Well, you've chosen everything down to the last specific detail, but what about thermal paste? Most people don't really put a whole lot of thought into thermal paste and just kind of use whatever comes with their components, if any is included, or just buy the cheapest thing they see. Does it really matter? Is all thermal paste the same? Well, I have 6 different pastes here, technically 5. 6 different thermal applications here to test and compare temperatures with, because I feel like most people don't really put a whole lot of thought into thermal paste, and some people can actually experience reduced performance due to poor temperatures and thermal throttling on the CPU, or even the graphics card if it requires a repaste. So we have some Arctic Silver 3 paste, we have some cheap no-name China stuff. It's Halnese. I have no idea how to say that. We have Cooler Master Master Gel. We have Thermo Grizzly Hydronaut. We have Thermo Grizzly Cryonot, and we have Thermo Grizzly Conductivity, which technically is not even thermal paste. It is a gallium mixture. People often call it liquid metal. So we're going to go over the cost of all of these, the watts per meter Kelvin, which is a measurement of thermal conductivity in all the different pastes, and then we're going to test them all. So recording Seth here. When I initially started the testing, I had all of my plans set out for the control groups, but unfortunately I had to make a few small changes. I did have the system crash in Prime 95 once or twice, so I had to go through and verify it was stable. So these are the settings I ended up going with. Initially I did lap the IHS on my 1800X. I have the multiplier set to 40, so the CPU is locked in at 4 gigahertz even. Voltage is set to 1.4 volts even. Line load calibration was set to 3. RAM was set to its default XMP setting of 3200 megahertz at CAS latency 14. And the pump speed on my X72 AIO was set to 100%, and I had 6 fans on that in push-pull, also at 100%, with an additional 3 intake fans, also at 100%. So this way everything was consistent, everything is even. I didn't have any room for fluctuation or deviance in the control group during testing. So all of that stuff remained consistent throughout the entire experiment. So without further delay, let's see the results. Also, I did not end up testing liquid metal due to the results that I found through the thermal paste testing. It would have been a huge waste of time and a waste of resources. So for the time being, we'll just be working with the data that I found of the 5 thermal pastes. Okay, so now we're going to lap the IHS of the CPU. This guy right here, as you can tell, maybe there's a decent amount of residue on there from when I had liquid metal. So essentially what we're doing is just sanding off a really small part of the coating on top of the IHS. So we're gonna add just a tiny little splash of water onto the sandpaper, and then you don't need to, but you can have shop towels and some isopropyl alcohol to wipe the top of the IHS off every now and then to remove some of that. So basically, I'm just going to hold the edges and just do circular motions like so. Alright, so as you can see, we have our CPU IHS lapped. Our first test is going to be the Hallanzi, whatever generic Chinese crap. So we're going to go ahead and apply a pea-sized dot on there. Is that all that's in there? Alright, so the verdict is in for the cheap China paste. CPU is currently sitting at 77 with a max of 77. We did have to up the voltage to 1.4. It did crash at 1.3 at 1. So all the tests will be done at 1.4. Fans are at 100. It's been sitting at 77 for a while here. So that will be our verdict for this paste, 77C.
When the time's right and I'm not alone.
So there being about 5.5 minutes into the test, Arctic Silver 3 has only reached a temperature of 70 degrees Celsius. So it's already 7 degrees less than the previous paste. So Arctic Silver 3, 70 degrees Celsius. Let's move on to the Cooler Master Master Gel.
When the time's right and I'm not alone, I will come with.
So for the Cooler Master Master Gel, we maintained a temperature of roughly 67 degrees for the entire test, going just a little bit over 5 minutes here. So that is where the Cooler Master Master Gel sits, 67 degrees Celsius. So after running for a little over 5 minutes, the Thermo Grizzly Hydronaut has managed to hold 66 degrees Celsius the entire test. So that is where the Thermo Grizzly Hydronaut stands, 66 degrees Celsius.
When the time's right and the mind low.
Okay, so after running this test for almost 7 minutes on accident, the Cryonot was sitting at 66 for pretty much the entire test. I believe I'm hitting thermal efficiency limits on my AIO. I think I would actually need a better cooling loop, like a custom open loop, to properly differentiate between the pastes. But we've already seen some deviance between those. So with that being said, I don't think I'm going to test the liquid metal today because I've never gotten it under 66. When I previously ran liquid metal on this setup, it was at 66. So as our tests show us, I was hitting thermal efficiency limits on that radiator. Yeah, it's a 360 millimeter AIO, which is probably one of the best sizes you can get in an AIO. However, it is a pretty thin radiator, being only 20 or 25 millimeters thick. So it's only able to dissipate about 120 to 130 watts, which is roughly what I was pulling out of my 1800X, having it set at 1.4 volts and clocked at 4 gigahertz. So to really see the differences in these higher end pastes, I would have to have a better cooling loop, something with multiple radiators able to dissipate more heat, so that way we could see which thermal paste was bottlenecking the heat transfer. So in this case, with an AIO, if that's what you're using, as long as you pick something half decent, you should be fine. You should be able to heat soak your radiator. But that's the issue with picking a bad thermal paste, is I don't like the term bottleneck, but that's pretty much what it does. Is that is the weak point of your thermal transfer, so you're actually not able to get all of your heat to the radiator to have it dissipated out of your loop. It'll be stuck under the IHS, causing your CPU to run hotter than it should, which is why we saw that cheap Chinese paste having my CPU sit at 77, is because it could not transfer the heat off of the IHS to the cold plate fast enough to heat soak the radiator like all the other pastes did, having it sit at 66 degrees Celsius. So yes, at this point, I would say I do need a custom open loop to really take advantage of some of this higher end paste. But let's talk about thermal transfer ratings, cost, and things like that. So here is the first paste that we tested, the cheap Chinese crap, the Halnzi. I don't know, what a ridiculous name. The HY710. I have the same stuff as this, except mine is in a little applicator tube, because that looks stupid and ridiculous. I'm not scooping it out of a jar. I'm not putting butter on toast. So I don't know what's up with that, but you can see right here 3.17 watts per meter Kelvin. So that is the rating that you are looking for with thermal paste. 3.17 is obviously extremely low. That is a horrible thermal transfer rate. Excellent thermal conductivity, my ass. So yeah, and it's $6.60 with free shipping. So that right there, I mean, it's dirt cheap. Super low thermal conductivity rating. Red flags everywhere. Stay away. A local PC shop actually recommended this garbage to me, and me not knowing anything about it, I bought it, I used it, and I was like, oh god, and temps are terrible, what is going on here? So yeah, that thermal transfer rating, that number, watts per I can't talk today, watts per meter Kelvin, that is the measurement that you were looking for to compare thermal paste with other thermal pastes to know how well it can conduct heat. So let's take a look at our next test subject. So after, oh my god, so much searching, I finally found the thermal conductivity rating for Arctic Silver 5. Yeah, and it's not Arctic Silver 3. The 5 looks like a 3 from kind of far away. Maybe I need glasses, I don't know. But every time in this video I've said Arctic Silver 3, replace that 3 with a 5. That's what I meant. So finally I found the rating for the thermal conductivity of Arctic Silver 5, and it is 8.9 watts per meter Kelvin. So as you can see, going from 3 point whatever the cheap stuff was, going up to 8.9, that about 5, a difference of about 5 watts per meter Kelvin net us a 7 degrees Celsius drop. So you can see the results are consistent with the thermal conductivity rating thus far. We still have a lot more to compare it with, but you can see the higher that conductivity rating is, the higher that number is, the better it's going to transfer heat. So that was 70C. Let's check our Cooler Master Master Gel and see what the rating on that is. Also, I forgot to mention the cost of the Arctic Silver 5, which is an okay paste, is about, it's $6.68 with free shipping. So there's no excuse to use cheap garbage when it costs the same as something drastically better. So the Cooler Master Master Gel is where we started to heat soak our radiator. This is our first result of 3 that got us down to that magic 66 degrees Celsius number. So if anybody is wondering, in order to completely thermal soak a 360 millimeter AIO, the Kraken X72 specifically, you need a thermal conductivity rating of at least 11 watts per meter Kelvin. So that's what the Master Gel is rated for. It is the 11, or it's rated for 11 watts per meter Kelvin, and this paste is only $10. So for $3.50 more, for just $3.50 more, you can get something that drops temps a lot more than the last paste. Because I mean, with my AIO being heat soaked, who knows what the temps could actually get down to if I had a proper cooling loop. So this is about $6 more than the cheap Chinese crap. 8 watts per meter Kelvin higher rating than that stuff, and it dropped 11 degrees Celsius. So if you can't justify $6 to drop your CPU temps 11 degrees Celsius, maybe you shouldn't be building computers. But yeah, so this is $10. It's good stuff. 11 watts per meter Kelvin, got down to 66 with that. So let's see what the other two are. They also got down to 66, but I believe the rating is a little bit higher. So people with more enthusiast grade cooling loops, people with hotter CPUs, GPUs, with a bigger heat load to transfer, might want to look into these other pastes. They are significantly more expensive, but you know, when you're dealing with way higher heat loads like HEDT setups and SLI, things like that, you can probably justify spending a little bit more money on something that will actually get your heat into all the radiators that you paid for. So here we have my favorite brand of all time, Thermo Grizzly. Their lower end stuff, the Hydronaut, is rated at 11.8 watts per meter Kelvin, so a little bit better than the Cooler Master stuff. It is $15, and this is 1.5 milliliters. I'm not sure what that translates to in grams, but it's a pretty big tube of this stuff. Like, you can bulk order these for not very much money. So if you're like me and you're doing a lot of builds, then you know, ordering the big tube for not a lot of money is extremely affordable. You definitely get your money's worth out of it. So with this being 11.8 watts per meter Kelvin, it works amazing. I really like their applicator tube. The syringe part, the plunger that pushes in, it doesn't get hung up. It's not real jerky. It's really smooth, and it's really easy to get just the right amount of paste. I know it's a really stupid thing to nitpick, but it's the little things sometimes that you notice that just make the product seem nicer than its competitors. So this is good stuff. It's pretty affordable. It's rated higher than the Master Gel. So yeah, all right, well, let's move on to the Cryonot. So here we have the Cryonot, also made by Thermo Grizzly. This is rated at 12.5 watts per meter Kelvin, so we're going up in pretty small increments at this point. This stuff is really, really good, super high end, and as you can see, the price is outstanding. It's 5.5 grams for only $20, and we're talking about paste here. So yeah, this stuff is awesome. Not really much more to say than that. I mean, the rating's high and the price is right. So yeah, most of these little thermal paste tubes are, I think, like 1.5 grams, and the Arctic Silver 5, I believe, is about $6.50 for 1.5. So this pretty much evens out and has a way higher rating. So this honestly would be my go-to. But something to note about this paste, when you go to apply it, make sure you wipe off the applicator on whatever you're applying it to, because when I was done, I just pulled it away. It's really stringy, and it like left a trail across my motherboard that I had to wipe it up. So this stuff is really stringy. It's kind of like hot cheese. When you pull it away, it kind of just attaches to whatever and stretches out. So be sure to wipe that off before you pull the applicator away from whatever you're pasting. But yeah, again, 66C, because that poor X72 just could not work any harder. But yeah, this is what I would strongly recommend. And here we have the god of all thermal interface materials, the Thermo Grizzly Conductivity. This is not paste. This is a gallium mixture, which is a metal with an incredibly low melting point. Thus where it gets its nickname, liquid metal. This is rated at 73 watts per meter Kelvin. So if anything is going to get you good temps, it is going to be this. Whatever you apply this to, it won't be the bottleneck for any temperature. It transfers heat. It transfers heat like nothing else will. The only thing to be wary of with this is that it doesn't play nice with certain metals like aluminum and I believe stainless steel. It will get incredibly corrosive, and it is also electrically conductive. You know, it's liquid metal, it's conductive. So if you get this on PCB traces or your capacitor, if it leaks out anywhere, it could cause some serious damage. But I did a video on liquid metal, and there's a lot of ways to mitigate those to where you can safely use it on components like a graphics card or a CPU without having to worry about anything. But yeah, the thermal transfer rating on this is amazing, but it is electrically conductive. So pros and cons here. But as far as thermal paste, I would absolutely recommend the Thermo Grizzly Cryonot. That is probably going to be your best bet as far as price to performance. So I hope everybody found this video useful as far as thermal capacity for radiators and having your thermal paste bottleneck heat transfer onto whatever you're pasting. Yeah, the different kind of pastes out there and how much they cost and what to look for. So if you liked the video, give it a thumbs up. If you didn't, thumbs down. Be sure to subscribe so you don't miss any future videos. And with it being the beginning of 2019, the start of a new year, there's a lot of interesting stuff that's going to be happening. A lot of really big changes to the channel and the way that I conduct business. So be sure to be on the lookout for that. So I will see you guys at the next video. Thanks for watching.